What is a number? For most of us, numbers are simple tools, counting, measuring, marking time. But what if numbers are more than just symbols? Imagine a world where numbers are the very essence of reality. This was the vision of Pythagoras, who saw the universe as a harmonious structure built from mathematics. He transformed numbers from simple tools into keys for unlocking the mysteries of the cosmos. Prepare to see numbers not as you learned them in school, but as the secret architecture of everything. Imagine looking up at the night sky. The planets move in a silent, graceful dance. Now, imagine someone telling you that this cosmic motion and the harmony of music are connected by numbers. This was the insight of Pythagoras, that both music and the cosmos are built on simple ratios. The Pythagoreans believed the universe was a harmonious masterpiece, governed by mathematical law. Today we still find this hidden symphony everywhere, from the spiral of a seashell to the orbit of a distant galaxy. We live in a universe built on number. On the sunlit island of Samos, around 570 BCE, Pythagoras was born, a man who would forever change how we see the world. More than a mathematician, he was a philosopher and mystic, whose travels to Egypt and Babylon inspired his vision. Fleeing political unrest, he journeyed to Croton in Italy, founding a school where mathematics, music, and philosophy revealed the universe's hidden order. The sage of Samos had found his stage to reshape the world. In Croton, Pythagoras founded the Pythagorean Brotherhood, a unique society where men and women lived, studied, and followed strict rules together. Members underwent years of testing and silence, seeking wisdom and harmony through mathematics, music, and a disciplined life. Their vegetarian diet and rituals aimed to purify body and soul. All discoveries belong to the community, not individuals fostering unity. Their influence grew, but secrecy and power bred suspicion, leading to their dramatic downfall. At the heart of the Pythagorean worldview was a beautiful idea. Numbers are the universe's building blocks, reflected in everything from geometry to music. The Pythagoreans discovered that musical harmony arises from simple whole number ratios. They believed the cosmos itself echoed this harmony, the legendary music of the spheres. The universe to them was a grand orchestra, its structure a testament to rational, beautiful design. For Pythagoras, numbers were alive, singing the song of the universe for all who would listen. The Pythagoreans didn't just count numbers, they saw them. Numbers became shapes, 1 as a point, 2 as a line, 3 as a triangle, 4 as a tetrahedron. This visual approach turned arithmetic into a dynamic exploration of patterns. By arranging pebbles, they revealed hidden properties. Odd numbers left a single point, even numbers split evenly. Numbers weren't just abstract, they built the world, forming the very fabric of space. Manipulating these shapes, the Pythagoreans discovered new relationships and patterns. For them, understanding numbers meant understanding the universe's structure. To see numbers as shapes was to glimpse the universe's hidden code. The Pythagoreans arranged numbers into geometric shapes, triangles, squares, pentagons, each revealing unique patterns. Triangular numbers grew by adding rows, 1, 3, 6, 10, and so on. Square numbers formed perfect grids, 1, 4, 9, 16, each built by adding an L-shaped gnomon. They explored pentagonal and hexagonal numbers, finding order in every shape. These patterns proved to them that numbers were not random, but structured and beautiful. Figured numbers linked arithmetic to geometry, showing that building shapes was the same as adding numbers. This interplay confirmed their belief number is the principle of order in the universe. The world's design, they believed, was hidden in these elegant numerical patterns. The tetractys, a triangle of 10 dots in 4 rows, was sacred to the Pythagoreans. It symbolized perfection. 1 plus 2 plus 3 plus 4, she, 10. Each row represented a step from unity to the three-dimensional world. The tetractys embodied cosmic harmony, mirroring musical intervals and the four elements. It was a visual key to the interconnectedness of math, music, and the universe. For the Pythagoreans, contemplating the tetractys was a spiritual act, revealing the universe's rational structure. In its simple form, they saw the divine language of creation. By arranging numbers as dots, the Pythagoreans pioneered number theory. They classified numbers by type: even, odd, prime, composite. Even numbers split evenly. Odd numbers left one over. Primes couldn't form rectangles, while composites could. They discovered perfect numbers, like 6 and 28, equal to the sum of their divisors. These explorations revealed hidden structures and universal rules. Their work laid the foundation for centuries of mathematical discovery. Numbers, they realized, had character and mystery beyond mere counting. The Pythagorean theorem, where A2 plus B2 orange here C2 was their crowning achievement. It united numbers and shapes. The areas of squares on a triangle's sides fit together perfectly. This wasn't just a formula, it was proof that the universe followed mathematical laws. The theorem bridged arithmetic and geometry, validating their vision of a world built on numbers. It opened the door to trigonometry and analytic geometry. For the Pythagoreans, this simple relationship revealed the cosmos's underlying order. In the humble right triangle, they found the key to the universe's magnificent complexity. The Pythagoreans believed the universe was built on whole numbers and their ratios, but their own theorem revealed a shocking truth. The square root of 2 could not be written as a ratio of integers. This incommensurable number shattered their worldview. Legend says the discoverer, Hippasus, was drowned for revealing it. Yet this crisis led to a deeper understanding of numbers, shaping mathematics forever. For the Pythagoreans, numbers were not just a way to describe the world, they were its very soul. Numbers, they believed, were the fundamental substance of reality, the eternal order behind all things. To study mathematics was to contemplate the divine, to seek harmony with the cosmos itself. For the Pythagoreans, numbers were the living heart of the universe, pulsing with beauty and meaning. The Pythagoreans believed numbers shaped reality, and nowhere was this more poetic than in their idea of the music of the spheres. They discovered musical harmony, followed simple ratios, and imagined the cosmos itself as a vast harmonious instrument. Planets, they thought, moved in perfect mathematical harmony, each producing a note in a cosmic symphony. Though we cannot hear it, the universe, they believed, is a grand, eternal symphony, its score written in the language of numbers. For the Pythagoreans, numbers were the key to the universe, not just for knowledge, but for spiritual purification. Their way of life aimed to free the soul from the chaos of the material world and align it with the eternal order of the cosmos. Through mathematics, music, ritual, and discipline, they sought to purify the soul, escape the cycle of reincarnation, and embody cosmic harmony. For them, the true meaning of life was to use reason to understand the cosmos and return to the divine whole. From pebbles on Mediterranean shores to equations on computer screens, the Pythagorean quest for patterns still shapes modern mathematics. Their fascination with numbers and geometry echoes in today's number theory, cryptography, and the search for symmetry. We've traded pebbles for computers, but the drive to uncover the hidden architecture of reality endures. Mathematicians continue this ancient journey, revealing the beauty and order woven into our complex world. The Pythagorean dream of a cosmos governed by numbers lives on. Newton's law of gravitation, string theory, and even our digital world all echo this vision, that the universe is written in the language of mathematics. From the fall of an apple to the dance of galaxies, math reveals the harmony of nature. Today we still search for a single beautiful formula, an ultimate symphony of the cosmos. Beyond the specific applications in math and physics, the greatest legacy of Pythagoras may be something more fundamental. The inspiration to look for order in a seemingly chaotic world. The Pythagorean revolution was at its heart a shift in human consciousness. It was the birth of the idea that the universe is not just a collection of random events, but an intelligible cosmos governed by deep and beautiful principles that are accessible to the human mind. This belief is the essential precondition for all science. Without the conviction that there are patterns to be found, there would be no reason to search for them in the first place. This quest for order, beauty, and harmony continues to motivate us today. When an astronomer maps the large-scale structure of the universe and finds that galaxies are not scattered randomly, but are arranged in a vast, interconnected cosmic web, they are participating in the Pythagorean tradition. When a biologist uncovers the elegant geometric precision of a DNA molecule's double helix, they are finding the numerical blueprint of life itself. Every time a scientist uncovers a new law of nature, they are affirming the ancient belief that reality has a hidden logic waiting to be discovered by a curious mind. The story of Pythagoras is a powerful reminder that the search for knowledge is not just about collecting facts. It is about finding meaning. It is about our timeless human desire to feel at home in the universe, to understand that we are part of a grand, coherent, and beautiful system. The Pythagoreans found this meaning in the harmony of numbers, in the music of the spheres, and in the perfect geometry of the tetractys. Their tools were primitive, and many of their specific conclusions were incorrect, but their fundamental insight that the universe makes sense was one of the most important discoveries ever made. And so the legacy lives on. It lives on in every student who feels a sense of wonder when the Pythagorean theorem clicks into place. It lives on in every scientist who feels a thrill at seeing their data align with a beautiful theory. And it lives on in every one of us who looks up at the stars and feels a sense of awe, not at chaos, but at the profound and elegant order of it all. Pythagoras taught us to listen for the universe's song. And for over 2.5 millennia, we have been learning to hear its magnificent mathematical music.